Uh, Good afternoon, everyone. My name's Jeff Lillycrop, and I'm a PIANC USA commissioner, and I'm going to be the MC for our webinar today on navigation lock design. And I'll introduce our presenters in a few minutes, but first, a little bit about our logistics for the presentation. Please put questions in the chat, and at the end of the presentation, we'll work through the list of questions and get them answered for you. Please make sure your mics are muted so that you're not a distraction to anybody else. And if you're interested in receiving a certificate for a CEU, please put your name and email address in the chat. Both will be very helpful for us as we get those out to you in the next few days. This webinar is being brought to you by PIANC USA. And for those not familiar with PIANC, we've been around a long time. It's the World Association for Waterborne Transport Infrastructure, and PIANC USA is the US chapter of PIANC International. And PIANC USA is led by the Corps of Engineers since 1902. And we definitely want you to visit our website, pianc.us, if you're interested in becoming a member. If you're not a member, please go to the website, and there is plenty of information to help you join. If you are a member, or if you're part of the Corps of Engineers or a corporate member, please go on to the website and register. That way it will ensure that we're able to get you the newsletters and the notices for working groups. We actually have some INCOM working group vacancies. I'm not sure if there are others, but there are 3 INCOM working group vacancies that we've got. Mr. Jose Sanchez from the Corps is the INCOM US lead, and he's looking for some members. So if you're interested, please go to the website, and there's information on applying to the positions. Let's see. So the webinar today is titled Navigation Lock Design, and it's being presented by John Clarkson, who was the, John was the chair of the working group, and he's joined by Eric Johnson, who was also on the working group. John was a Corps of Engineers employee, recently retired from the Inland Navigation Design Center. Eric is still a Corps employee working for the Inland Navigation Design Center. So we've got some great expertise, and there was a lot of work put into this working group and the design guidance that they've come up with. So with that, I'll turn it over to John and catch up at the end of the presentation to help with the Q&A.
Let's go to
John?
Muted, but that's good. Good thing.
Yeah, thank you, Jeff, for that introduction. My screen is loading. Just give it a second. There we go. Can you see my screen?
Yes.
Yes.
Okay. It's my pleasure to present this effort. So this is a larger effort than a normal working group. This is, we updated a 1986 report. It was very beneficial for my career, and it helped me see that there were other ways to design locks. And so I noticed a few years ago that it was pretty stale, that the designs were old. No one would use most of the stuff that was in it, so we decided it needed to be updated. So, you know, the purpose is just to come up with a new comprehensive design handbook, and we concentrated on best practices and innovations since the 1986 report. So we divided it up into chapters, and our presentation is going to be based on that, so I won't read those to you. So chapter 1 is the general aspects. That was my chapter, and Erwin Pechtold and Lance Oswald helped me. So again, you know, the report was 40 years old. We changed the name of the report to the Design of Navigation Locks. That sort of more described what we're trying to do. You know, lock design is a very complex, huge effort. So we have a lot of design guidance and a lot of lessons learned from 70 experts around the world. So just show you some nice state-of-the-art locks. This one's in Belgium. I've been there. This is Panama Canal, and you can see the water savings basins. And I've been there. This one's Terneuzen in Amsterdam. It's a ship lock, and I'll just note this sliding gate here. It also works as flood defense for the country. As most of you know, the Netherlands flooded horribly. I think it was 53 or 56. So that flood control is a big part of their mission. So like I said, the working group started in 2019. And of course, we all know what happened in 2020. We had COVID. So we did most of our interactions virtually. And so it did take us a little longer to publish than we hoped, but I'm really pleased with the effort that we made. I was just talking to Jeff before we started that we had the A team on this. I was really proud of each and every one that we had in the group. Okay, so the value of navigation, it's the most efficient and the most sustainable transportation system, and it's the safest. The navigation is so important to the country. Most cities in the world are built on the banks of rivers, and navigation helps support that whole function. And it's just really important to every nation's economy that you get it right. And so hopefully this design book will help do that. So we believe this document will be a legacy document for years to come. Hope that if you're doing a lock, you at least look at some of the things in our handbook. Chapter 2 is on how to plan a lock. So, planning varies through each country, but some of the universal things is you have to, a lock there's just a lot of trade-offs between the functions, a lot of iterations. So it's a drawn out process, and we cover a lot of the different things that you need to consider, including checklist, a lot of references. So there's how the chapter is broken down into. And it works like on functional requirements. What do you want the lock to do? Obviously, you want to transport vessels, ships or barges, but it could be, fish passage, a bridge providing road access across the waterway. There's lots of functions, and you have to balance all the stakeholders and all the needs to come up with the optimal solution. So obviously you would start out with the vessels. This is the European experience. Here's the American, what we use. An important criteria for the lock is what is the ultimate capacity of the lock. Someday you'll reach that, and you of course you need to design for that capacity. The capacity is controlled very much by the lock dimensions, but it's also the lock approach is really important as well. So other things you have to consider early on in the design is, the number of gates, the lift, the type of gates, the fill empty system. Will you have water savings basins? And there's a decision tree to help you get through that whole process. And here's some of the other issues you need to take into account: design life, adaptability, aesthetics, and it relates to the construction methods, which we'll discuss later, maintenance, rehab, and of course, could be flood defense. So planning is chapter 2, 3 is lock types, 4, 6, 7, 8, 9 is structural gates and valves and hydraulics. Then we have construction, how to operate it, what equipment you'll use, and then as it's operating, you need to inspect it and maintain it, and eventually someday you'll have to rehab the lock. So chapter 3 is on lock types. So, they can come in all kinds of shapes. We always say every lock is the same and every lock is different. They're the same because they have 2 service gates up and downstream, but how you do that, it's very different. This is in Southern England. I hope to visit that in August. So this is just an example of a lock wall, of a lock. In Europe, they have a lot of bridges over the waterways. Therefore, the ships don't have a lot of air draft, and so they can put permanent structures. And just want to show you, there's a lot of different ways to do locks, as you probably know. Here's an example of locks of unequal length. Here's a longer one and a shorter one. Now we move into structural design. So you have to select your lock walls. What are you going to use? A lot of different functions. A lot depends on the geology of the site, and then, of course, what are the loads, what materials will you use, and what's your design criteria. So for that, there is also a decision tree to help you get through it. And you'll have to come up with a reinforcement scheme for concrete, as most lock walls are concrete. So anyhow, the walls interface with all the different functions of the lock. And then you'll have equipment that needs to go along with the lock. Equipment generally falls into 3 different areas. It's to facilitate the lock operations. It provides safety for the crew and the operators, or it helps protect the ship or the locks for like wall armor. But that's all just discussed. So, just all the different types of decisions that have to go, they're covered as you go through your choices on what kind of equipment you need to use. So here's tires at the end of the lock wall. This is a floating donut. As the ship hits this monopile pile, it spins around. That's in Emden, Germany. I've been there. Some ship protection. Here's a cable that protects the ships. And we've got a floating mooring bit here and just a regular check post here. This is a new design in the St. Louis Seaway. It uses vacuum to attach itself to the side of the ships. So it frees up a lot of labor. You don't have to drop a man overboard to man the lines as you go through the lock in the St. Louis Seaway. So it's been a successful program there. If you get to saturation point, you can put travel with capacity. You can put in traveling kevels. We use those quite a bit in some of our southern locks. And then here are just some safety ladders. So the chapter and gates, valves, and temporary structures, it's quite extensive. There's a good deal of information to, again, help you pick out what type of gate you need to use and the loads that go on it. Here's a long list of the different loads that need to be considered, from buoyancy, waves, ice loads, seismic, misoperation, vessel loads, vessel impacts, and then how do you drive it? All of that's covered, including vibrations and fatigue. So each gate is covered by the description. How do you frame it? What's embedded, the bearings, what operating machinery, and of course the advantages and disadvantages of each type. So we're probably all familiar with the most common type is miter gates. Here's a timber on the left, and the one on the right is some composite gates, the world's largest composite gates in Holland. Here's a single leaf gate, and if you'll notice, the fill empty system is through the gate on the bottom, so it's a low lift lock, but different ways to do things. Here are some sector gates. I believe this is probably in New Orleans district. They can resist loads in both directions, so they're good for tidal locks. Here's a radial gate. It rolls up and down, spins across this bearing. A rotary segment gate, which is similar, except for the gate spins down and rests on the bottom, and the vessel goes over it. Hinge crest flap gate. It's got a strut arm that drives it, so it rests on the bottom and you bring it up to stop the flow of water. Here's a vertical lift gate. I believe that's in the Bonneville Basin. Here's a rolling gate. I pointed that out earlier on the Turnesian. It fits in this pocket recess and rolls out. Here's a sliding gate, which I think uses water or air to float up. So it's not a rolling gate, but very similar. So it doesn't have wheels, and the buoyancy is taken up by water or air. I'm not sure. Now we're moving into the fill empty system. Here's a radial tainter gate. You could have butterfly valves. You can have vertical lift valves, sometimes called stony gates. If you need to work on these areas, you have to float in these or lift in these bulkheads, or sometimes called stop logs, depending where you are. And here's a set that floats in, so you don't need a crane to lift those in place. So anyhow, Chapter 6 has 150 pages, over 100 photos. It would be a working group by itself. It wasn't part of us. But if you've got gates design, I hope you check out our report. With that, I'll turn it over to Eric.
All right. Thanks, John. I'm just going to switch screens real quick. All right. No, thank you, John. And also big credit to John. If it wasn't for John, this working group wouldn't have happened. It was his idea. And then also a lot of effort, him being the chair and leading us, this huge group, monumental effort through it. Also too, like we said, this report is over 600 pages. So we're just going to cover the highlights, and including with the hydraulics has probably over 100 pages in itself. So a lot of detail there. And I'd highly recommend this not only for, experienced navigation engineers, but I think if I had a new navigation engineer starting, I'd hand them this report as a great introduction and being aware of what all is out there as far as the navigation body of knowledge on designing locks. So this part will touch on, the hydraulics aspects, water savings basins, and also saltwater intrusion. And this was the team that worked on those chapters. So just some of the contents of what they covered in that chapter related to hydraulics. Now, a lot of things, go into the design criteria of hydraulics, including the filling and emptying system, forces acting on the vessel, flow conditions, some of the special topics such as cavitation, air entrainment. And so all those are things that have to be taken into account. This is just showing, one of the biggest decisions in designing a lock is selection of the filling and emptying system. And that can have a big impact on cost as well. And so looking at the varieties that are out there, there's filling and emptying through or around the gate, such that we see with some sector gates or lift gates. Then there's also using longitudinal culverts and ports, and that's what's most common in the US with our larger locks. But we do have some that fill through gates on smaller locks. Also, there's filling and emptying systems through the bottom of the lock chamber too. And this is typical for higher head and large locks. And so there's trade-offs, pros and cons with all these different filling and emptying systems, and deciding which one is the best fit for the specific lock. So this is some of those considerations when selecting a filling and emptying system, and when going through that. So then also, one of the things with filling and emptying systems is figuring out the forces on the vessels and the lines. And so that has to be evaluated and determined and met so that we don't have too high forces on the lines. Also, there's special things like, how to avoid cavitation. One of the big things we found through the working group is there's a very good hydraulics expert in Belgium that's done a lot of research on cavitation. So also knowing those experts in our navigational design network that we can reach out to for special topics like this. So some of the design tools and methods for hydraulic design, can include numerical models, physical models, hybrid models, and then navigation simulations. And these are just some of those that are shown there, some numeric, a physical model. I think this was from Deltares on one of the large lock models they have there. So switching gears to water saving basins, when and why should we use those? It's typically for water systems that don't have a large water supply and where water is critical. Not as common in the US, I would say. Fortunately, we have some pretty healthy water drainage basins that supply our rivers. And some of the downsides are, it can increase transit time. Also, it's more maintenance. Also, it can cause trouble with salinity. So that was with the water savings basins. Then transferring into, some of the saltwater intrusion that can happen. These are more on coastal locks, but our colleagues in the Netherlands have faced this quite a bit. So, as you have a saltwater lock, the salt tongue comes in and tries to replace the fresh water. And so you're using fresh water or systems to keep that salt water from propagating up further into the canal or river. So these are some of the mitigation systems for saltwater intrusion, as far as air bubbler screens, physical barriers, flushing, salt screens. And so there's been a lot of looking into this and a lot of good advice in this chapter. So concluding up the hydraulics chapters is that, there's a lot of criteria and aspects to consider and how we, analyze those with numerical and physical modeling. And the main thing is, there's always needs to be a balance to find between, performance, safety, cost, and maintenance. And then seldom does, an ideal solution exist. So it's trying to find the best fit. Next, we'll cover control systems and lock operations. And the author, Tim Paulus, is joining us today. So this is looking at controls, communication, security, lock operating training, and ice and debris control. This is just kind of showing the logic that's involved with safety interlocking systems and the design logic that goes into those. Communications and equipment is very important to controls and operations. As far as radio communications, self-spotting systems, which is shown there on the left at the St. Lawrence Seaway, and television equipment and cameras. Also, this is on the right is showing their distance as that they're approaching the gates. One of the big takeaways from this too for the US audience is that many of our colleagues in countries that we partner with are really advanced on this remote lock operations topic. Belgium, Netherlands, and Canada all have this figured out pretty well. And there's a lot to be learned and gained from their knowledge and experience and expertise. Here's an example of training remote lock operation simulators with their panel and viewing all the different inputs and controls. And then also there's ice and debris control at locks. This is a picture up at the Sioux locks where there's a lot of ice. But trying to control this so it doesn't impact or we can minimize the impacts to navigation and lengthen the seasons. So some of those methods include, ice booms, air bubblers, heated gates, ice flushing, scraping ice, and repellents. This is showing one of those bubblers in action at the Sioux locks and how some of the bubblers are laid out to prevent and keep ice away from the gates so that the gates can still operate with ice around them. Or in the case of this one, a bubbler array to try to divert ice away from the lock. So with that, now chapter 11 is about construction, and the main author on that was Charlie Thomason from INDC. And so we want to look at the different construction methods, pros and cons. The main two are in the dry and in the wet, and then construction and design can often be a little bit iterative working through it. So we'll first look at in the dry, some of the benefits of this, and this is shown as Chickamauga Lock and Tennessee. Benefits, kind of tried and true, familiar, conventional equipment, methods, and personnel. Limitations of some of this are, time and cost for building the cofferdam, a larger project footprint, especially sometimes, when we're building next to an existing lock that's in operation, we have a limited footprint. That's one of the common challenges and biggest challenges that this report looks at and tries to address is that most navigation locks built today are next to existing locks, and there's a limited footprint, and we have to maintain traffic through that existing lock while building the new lock, which creates a lot of challenges. And the additional risk of a cofferdam is overtopping. Now in the wet, it has some benefits of potential cost savings, schedule savings, and fewer impacts to navigation and when we're in tight spaces. Some of the limitations, though, is sensitive to river velocities and depths. We found that out from Olmsted that with high fluctuating water levels of 40 feet or more, it makes it very difficult for construction. And then there's sometimes new construction techniques and required qualifications to do those. So in the wet, there's two subsets, there's float in and lift in. And what's shown here is a novel kind of design was developed in Pittsburgh of basically lift-in wall panels forms that can be formed against to form a concrete monolith or box for a concrete wall and then removed and reused. So float-in, is more sensitive to river velocities and more complicated units because we're basically creating a barge that has to be floated in and sunk. Lift-in requires larger lifting equipment because it can't be floated in, and less complicated units because you're not designing it to float. So that's basically the summary of the construction chapter. Then moving on, chapter 12 is inspection and maintenance. And chapter 12 and 13 I helped lead, but had a great team shown here, and many of those are some of those, especially from the US, and are joined with us today. And it really helped to have a diverse group with a lot of expertise. So these were the different areas that we covered for inspection and maintenance, everything from asset management to reliability and inspection. So a lot of the things, and this can speak for a lot of different things, but thinking about the process. So, first getting information through inspection, assessing that data to figure out what the right path forward is, and and then all this, and then working towards maintenance and what maintenance is required. But asset management is really the key and central part of all this to manage maintenance and also rehabilitation. So, but with anything too, a lot of it depends on what level of service is appropriate to how much money and inspection and level of care that we put into different lock and dam systems. And so, that's the main thing, is to work with the owner and asset manager to develop that acceptable level of navigation outages depending on usage and importance. There's the different maintenance types. There's planned and unplanned maintenance, or scheduled and unscheduled, and trying to keep things more in the preventative planned maintenance side than unscheduled. This was something interesting too, comparing amongst all our international colleagues of the different inspection intervals they used. And it's fairly common across all the different navigation owners, is that there's typically a routine and operational short-term inspection, and that can be a 1 to 3 months. Intermediate, which is medium to long term, but typically, like in the Corps of Engineers, we call them periodic inspections that we do every 5 years, and that's pretty much in alignment with most of the other asset owners of doing a comprehensive, regularly scheduled inspection of major facilities every 5 years. But as needed, if something's in poor condition or operation, it requires shorter term and more frequent inspections. And if it's performing well or is new or something, it may require longer term inspections. And so, of course, too, there's always emergency inspections when required. So the main wrap up for these were, looking at different levels of service, what's appropriate, monitoring condition, and determining what the appropriate maintenance is. Last chapter in the book and report is on rehabilitation and modification strategies. And this is the same team that was involved with chapter 12. This is really kind of a heart of what we're working with now, especially with all the existing infrastructure we have, and how do we fix and improve it. So with that, the topics that were covered for this chapter are rehabilitation, modification, and structural, mechanical, electrical rehabilitation, and we'll hop through those. Here's a picture of what was shown for LaGrange Lock and Dam, which is a major rehabilitation, typically a 90-day closure, while navigation is out, but to try to repair and get navigation going again as quick as possible. So a very intense 90-day period of dewatering the lock, removing damaged lock walls, replacing them. That's what's going on right now, is shown in the picture, is removal of damaged concrete and replacement of concrete, but also replacing gates and doing a lot of definitely major rehab in this photo. Reasons for rehabilitation. So we might need to improve the condition or performance. Also, we may need to modernize, based on technology and efficiencies. And also there may be new regulations, standards, safety requirements that would be a reason for rehabilitation. Also, there may be another term we used was modification. So if the structure needs to be, changed in size or function, that would be a modification. So, and this is an example that Josh Rupp, who's on, worked on. The strand lock it actually was large, and reducing the size, or actually this one's lengthening it. to make it more functional. So that was a lock extension. So for structural rehabilitation, that can include lock wall resurfacing, guide wall rehab, gate and valve anchorage replacement. That's where the gates and valves are connected to the concrete. And then also we may have to replace or renovate the steel structures such as the gates. So one of the neat things was concrete demolition techniques. So there's a lot of different techniques, and different ones have their advantages in different situations. But one of the newer, to get rid of a lot of concrete quickly, blasting is very effective, and then also hydroblasting has also become a lot more popular to remove concrete, and you can see how pretty strategic it can be used in certain locations. Locked wall resurfacing was also another best practice shared in the report. These are precast panels. It accelerates construction speed. You get higher quality concrete because it's done in the shop and trucked to site, and easier for cold weather construction. And as we look at the future, we're looking at using ultra high performance concrete, which for these precast panels, which would allow for thinner panels, so less concrete removal, which would be quicker and cheaper. Also, UHPC has a higher abrasion resistance, which could eliminate the need for wall armor. With a rehabilitation, there's also all the electrical equipment and cabling that could be needed to be replaced or rehabbed, and that includes rewiring, control systems, automation software, a whole variety of things. Mechanical rehabilitation also, rehabilitating the machinery that operates the gates and valves, changing the machinery. For instance, if we're going from electrical mechanical to hydraulic cylinders or vice versa, and elevating machinery above flood levels. So maybe initially it was built at a low level, elevating it so it's out of the flood area. And these are just some of those components that are typically rehabilitated on the mechanical aspects. So in summary, rehabilitations can vary in size and scopes. They have typical challenges of limited funding and outage time, and the overall goal is to improve the service level. So overall, wrapping up the total working group 206 design of locks report, the primary purpose in what it delivers on is providing a definitive reference balancing the rigorous engineering, environmental stewardship, and long-term adaptability for future transport demands. It addresses the design constraints of building new locks directly adjacent to active and operating locks. And one of the big advantages is this consolidates unmatched international expertise by opening up new design methodologies for engineers in the US that research alone can't replicate, that real world experience. And also, PIANC is an incredible, rewarding global collective effort, and the network of experts that is there to pick their brains and get expertise is invaluable. So we'd like a big thank you to all the authors that were involved in this report. You can see there was a lot of people that contributed their time and knowledge to this report. And you may be wondering, where can you get working group reports, including this working group 206 report? So this is, if you're a member or non-member, you can get it at the PIANC website. I'll include that in the chat in just a moment. And for members, it's free. So you log in and it's a free download. For non-members, it's available for purchase. If you're in the Corps of Engineers, it's available on the INDC Knowledge Management site. And I'll include a link to that. And then you may wonder too, how can I get involved? So if you have a problem that is common to International Navigation community, you can write a terms of reference for PIANC to consider developing a state-of-the-art report such as this one. Now, this one was huge compared to most PIANC working groups. Most of them have a working group report that's, say 50 to 100 pages, and it's a much more focused topic. This was a huge effort, but it was needed for kind of capturing the holistic and all the different aspects of lock design. So you can always reach out to me or Jose with any ideas you have for terms of reference. You can apply to get on working groups, as Jeff Lillicrop brought up at the beginning. Typically, there's 2 members and 1 young professional per country per group. But even with that limitation, there's no limits to join a national team. So like say there's a working group on evaluating infrastructure. Even though there's maybe only 3 official members on the working group from the USA, you can apply to be a national member or contributing member to that group. And then understand there are challenges on funding for participation, depending on whether your organization or company will fund it. And just to give you a quick idea of us, I'll just go through these quickly, but just for awareness, what active Inland Navigation Committee working groups are ongoing right now. You can see there's a variety of things out there. Now, some of these are more, it covers everything from shipping facilities to ship operations to some of the infrastructure. So as a navigation lock designer, not all these would be applicable, but some of the ones that are, like the working group 255 and structural reassessment of existing inland waterway hydraulic structures. That's one, near and dear to Inland Navigation Design Center, and Gary Grunwald's involved in that. And then there's also some others in there too. You'll see there's one, I think, on a remote operated inland waterway navigation, but that's from a vessel focus and not lock operation. There's also upcoming and proposed working groups that are in the works. And this is a list, I won't go through it all, but those are things that are in the works, and of particular interest to maybe some of them were, like lock designers that may be involved, or some of the ones with cybersecurity, and the updating composite hydraulic structures and standardization of equipment. So with that, we appreciate your patience in joining us today in your busy schedules. And if you have any questions, we'd be happy to answer them.
That was a great job, Eric and John. Just feeding off of your last slide there, Eric, there are some vacancies in 3 working groups that INCOM is trying to put together. If you're interested, as Eric said, a primary and alternate and a young professional. Young professionals are 40 years and younger. So we're definitely recruiting, and if you're interested, there's a summary terms of reference on each of the working groups that are being, the positions are being advertised for. If you go to the PIANC.us website, you can get more information, and from there it will lead you to a link to submit your name for consideration. So I urge you to please take a look and get involved. With that, I think we've got plenty of time for questions. We had a couple in there near the start. Bob Bartlett asks if you could address